Hello class, this will be the last video for section 5.1. Split this up into three parts. Now we're going to look at solving a system of three equations with three unknowns. So if we're in three unknowns, we're in some x, y, z, some three-dimensional plane. So we have different options of what it can look like to be a solution in a three-dimensional plane. Remember, in two dimensions, if we have two lines that cross, that one point is the intersection. If they are parallel lines, then they will never intersect, and so there's no solution. Or they can lie directly on top of each other, the two lines, and then it's infinitely many solutions. Similarly, in three unknowns, three dimensions, we can have the same thing. So the top left here, we can say that this is a single solution. There is one point where all three of these, and now we're going to think of it in terms of a plane just for visual purposes. So if I see the Roman numeral 1, 2, and 3, those represent three different planes. Well, there's one point P here that they all intersect, and so that would be a single solution. Moving to the right, points of a line in common. So we could have some line that all three planes cross through. And then we could also have the third one, points of a line in common, if equations 1 and 2 represent the same plane, and then they intersect plane 3 along one line. And then all points in common would be if it's the same plane for all three. Now moving on to the next row, this one, no points in common. You could think of these planes are parallel to each other. The second one, no points in common, meaning not all three of them share the same point. We can see there's an intersection here of planes 1 and 3, and an intersection here of planes 2 and 3, but that is not for all three, don't have the same spot in common. Same one with this A shape. There's only an intersection of two planes. And this one, the third one, or the last one, would be parallel planes as well. All right, so let's actually look at solving a system of three equations with three unknowns. Okay, I already have down here, but this is going to come into play after I've done everything. A final answer when you have three equations with three unknowns will be some point, but now it's x, y, z. And this is called an ordered triple. So it's not just some coordinate point x, y, it's some actual coordinate point x, y, z. So how do we do this? Step one, eliminate a variable from any two of the equations. So again, we're gonna have three variables, x, y, z. If we can eliminate a variable from any two of the equations, we're on the right track. Step two, eliminate the same variable from a different pair of equations. So if our first pair of equations, we eliminated z, now we're going to choose two other equations and eliminate z. Step three, eliminate a second variable using the resulting two equations in two variables to obtain an equation with just one variable and solve. This is what we were doing when we had a system of two equations. This right here. It's a lot of words, but it's just solving a system of two equations. Step four, find the values of the remaining variables by substitution. So we solve it out and we end up with x equals 5. Well, we can substitute that back in to determine what y and ultimately z will be. All right, so let's actually look at one. If I wanted to solve this system, okay, so the first thing I want to do, let's eliminate z, and let's focus on just these two equations first. Well, I know if I add these up, these are already set up nicely. Or when I add this together, I end up with 3x plus 2y plus 0 equals 4. So there's one equation that I have 3x plus 2y equals 4. Well, now I also want to focus on eliminating z from the top equation. All right, so if I want to eliminate z from that top equation, I could focus on these two and figure out, well, how can I eliminate z from those two? Well, if I multiply by 6, I'm going to end up, and I'm only going to multiply the bottom one by 6. I'll end up still with my 3x plus 9y plus 6z equals 3. But now multiplying by 6, this is going to give me 12x plus 6y minus 6z. That's the key piece. That's why I did all of this. And still multiplying the 2 by 6 to get 12. Now I'll add these together and my z's will eliminate. So I end up with 15x plus 15y equals 15. So now I have two new equations that I'm working with here. 3x plus 2y equals 4. 15x plus 15y equals 15. So now I only have two equations that I want to work to solve. So let's focus on just those. So 3x plus 2y equals 4. 15x plus 15y equals 15. So now I'm at where we're on the very first part of section 5.1, trying to solve a system of two equations with two unknowns. So in order to solve this, I'm going to multiply the top by 5. So now I end up with 15x, and let's actually do it by negative 5. So negative 15x minus 5y, minus 10y is going to be equal to a negative 20. And then I still have 15x plus 15y equals 15. Add to eliminate. So negative 10 plus 15y is going to leave me with 5y equals negative 20 plus 15 is a negative 5. So therefore, y equals negative 1. So it took all of that work just to solve for one variable. But now I know y equals 1. I can start going back and solving. So let's look at this one. If y equals 1, so 3x plus 2 times negative 1 equals 4. So this is 3x minus 2 equals 4. So 3x is going to be equal to 6. 6 divided by 3, x is equal to 2. So we have that one easily we can solve. Now I need to figure out my z value. Well, I'm going to pick, let's go from this one right here. Sorry for all the mess. So x plus y plus z equals 2. I know x is 2. I know y is a negative 1 plus z equals 2. So this is going to be 1 plus z equals 2. So therefore, z had to be 1. So I have my x, my y, and my z. Writing this out in three variable coordinate form, it'll be x, y, z. So 2, negative 1, 1 will be our solution for all three of those equations to make them equal to each other. All right, we can also work a system of two equations with three unknowns. So say we had x plus 2y plus z equals 4, 3x minus y minus 4z equals a negative 9. Okay, so very similar, we want to eliminate a variable. All right, so for this one, let's eliminate x. In order to eliminate x, I'm going to multiply by negative 3. So I have negative 3x minus 6y minus 3z is going to be equal to a negative 12. And then 3x, this stays, minus y minus 4z equals negative 9. Add to eliminate. So I've eliminated the x. So this is a negative 7y minus 7z is going to be equal to negative 21. If I wanted to solve just for z, so I could say negative 7z is going to be equal to 7y minus 21. Divide both sides by my 7, my negative 7. I would end up with a z equals now a negative y plus 3. So in this case, we're not getting a number, we're getting an equation. So z is negative y plus 3. So we'll come back to that in a minute. Okay, another thing we can work with, well, we know our x plus 2y plus z equals 4 from our top equation here. Let's solve this for x. This would be an easy one to solve for x. X is going to be equal to negative 2y minus, instead of our z, we're going to use our new equation that we found. Okay, so z is this piece, negative y plus 3, and then still plus 4. All right, so we can simplify this. So this is negative 2y plus y minus 3 plus 4. So this is going to be a negative y plus 1. This is x. So x is negative y plus 1. Z is negative y plus 3. In this case, this system has an infinite number of solutions. Doesn't matter for any value of y, the value of z will be negative y plus 3. For the value of x, I have negative y plus 1. So let's test this out. If we chose y to equal 1, then x is going to be negative 1 plus 1 to get 0. Z is going to be negative 1 plus 3 to get 2. So this would give us a solution. Our x we ended up found was 0. Our y we chose was 1. And our z we end up with 2. All right, because I chose y equals 1, I mean, I could have chosen y equals 2, y equals 5, y equals negative 7, and I would still end up with a coordinate of 3 points. So with that variable piece that I can choose what y is going to be, my solution set is actually going to be in 3 variables. My x, well, x is really negative y plus 1. Y I can choose. In z, z is negative y plus 3. So for this one, this would be the solution where I'd actually have expressions for my x and for my z that I'm putting in there. Last one, find an equation of the parabola y equals, in the form y equals x squared plus bx plus c that passes through these points. So if I were to graph these points, over 2, 4 would be right about here. Negative 1, 1 would be right about here. Negative 2, 5 would be up here. So I know there's going to be some parabola going on, and I'm trying to find the equation that models this parabola. Okay? What they're giving me here now with these points, 2, 4, negative 1, 1, negative 2, 5, those are my x and y values. All right, so based on this equation, y equals ax squared plus bx plus c, I can set up 3 equations. I can say, well, y is going to be equal to a times my x. We'll look at the first one, which is 2 squared plus b times 2 plus c. And again, this equals y, but I know my y is 4 for this first coordinate. X is 2, y is 4. I'm just going to substitute those directly in there. I can also do this for the second one. My x is negative 1, so this is negative 1 squared plus b times negative 1 plus c equals a positive 1, because that was my y coordinate. And then on the last one, a times a negative 2 squared plus b times negative 2 plus c, that one has to equal 5. So let's clean this up a little bit. So I know now my 3 equations are going to be 4 equals 2 squared is 4, so 4a plus 2b plus c. I know my other equation that I can work with is 1 equals a minus b plus c. And my third equation, 5, is going to be equal to 4a minus 2b plus c. So now I have 3 equations with 3 unknowns that I can solve. All right, so if I wanted to solve these, let's just look at these first two and do some elimination. Well, I know if I multiply by -1, that's going to eliminate my c's. So let's go ahead and do that. So first equation, 4 equals 4a plus 2b plus c, we're going to leave as is. But the second equation, let's multiply by -1, so we get a negative c. So this would be -1 equals -a plus b minus c. We add to eliminate, our c's go away. All I end up with is 3 equals 3a plus 3b. Now let's see what we can do to eliminate the second equation. If we wanted to do our elimination here on these ones, again, c is that lone variable out there. I just need to make it negative. So let's multiply the second equation. Let's multiply this one by our -1. Okay, we're going to multiply the second one by -1. So now I have 1 equals a minus b plus c, and now -5 equals -4a plus 2b minus c. We'll add to eliminate. -4, a 1 minus 4 would be a -3a plus b, and my c's are eliminated. So now I'm down to two equations with two unknowns. Let's solve these. So 3 equals 3a plus 3b. -4 equals a -3a plus b. We don't have to do any multiplication because our 3's are already opposites of each other. So we're going to add to eliminate. -1 is going to be equal to 4b. So therefore, -1/4 is equal to b. All right, now that we know what b is, let's see if we can put that back into equation to make things a little bit easier. Let's put this b back in over here. So we have 3 equals 3a plus 3 times a -1/4. So this is 3 equals 3a minus 3/4. We can work this all out. A ends up being 5/4. So we take 3, add 3/4, divide by 3. A would be 5/4. Now we have A, we have B. Our last step would be to figure out what C. For C, I would probably just pick this equation up here. This one down here. So we have 1 equals A, which we found was 5/4, minus B, so minus a -1/4, so we could say plus 1/4, plus C. We work this all out. C ends up being a -1/2. So now we have our A, we have our B, we have our C. So our equation ends up being 5/4 x squared minus 1/4 x minus 1/2. Or if we wrote this in decimals, this is 1.25 x squared minus 0.25 x minus 0.5. So here is our equation that contains these 3 points that we initially started out with. If we want to see it graphically, this is what this equation graphed is. 1.25x squared minus 0.25x minus 0.5 is a parabola that looks like this, and shows right here that those points are contained. They are on the line of that parabola. So take a look at 5.1 part 3 in Math Excel, due Sunday 4/5 by midnight.